A tangent line was a line that touched a curve in one point. So we learned in geometry, we talked about tangent lines in terms of circles, but here is a tangent line. The problem is that the tangent line could look like that, or it could look like this, or it could look like this, because all it has to do is touch the line in one place. So in order to find the slope of a line tangent, we're going to use our limit properties to find the limit of the slopes of all the lines going through that point as we get closer and closer to that point. So the definition of the slope of a tangent line is going to be the limit as x approaches a of f of x minus f of a divided by x minus a, where the point that the line goes through is at a comma f of a. Let's use that formula in example 1 to find an equation of a tangent line to the hyperbola y equals 3 over x at point 3, 1. Well, first of all, remember that this is f of x. And then the point that the line goes through is at a comma f of a. So the slope is going to be the limit as x approaches 3, because a appears to be 3, of the original function minus the function when you plug in a, or f of a, which happens to be 1, divided by x minus a is 3. So we're going to have to do some mathematical manipulation here, because right now I can't plug 3 into that function. It makes the denominator undefined. So what we're going to do is we're going to start by simplifying the numerator into a single fraction. I had a little way of doing that. It was 3 minus x over x. So the limit as x approaches 3 of 3 minus x over x divided by x minus 3. Now I have a single fraction in the numerator, so what I can do now is I can multiply the fraction in the numerator, 3 minus x over x, times the reciprocal of the fraction in the denominator. Ooh, those x minus 3's are almost the same thing. I wonder if I can reverse 3 minus x and make it x minus 3. Well, remember that you can, but in order to do that, you have to put a little -1 in front of it. So the limit as x approaches 3 of -1 times x minus 3 over x times 1 over x minus 3. Now I can get rid of these. So now I want to find the limit as x approaches 3 of -1 over x. Now I can plug in 3 for x, and that's going to equal -1/3. Now that's just the slope of the line. Now I have to go back and find the equation of the line. Well, remember, the line goes through the point 3, 1, and it has a slope of -1/3. I could use point slope form to very quickly and easily write the equation of the line. So y minus 1 is equal to -1/3 x minus 3. You don't even have to distribute and simplify it. You can leave the equation in point slope form. There's another equation for finding the slope of a tangent line that can sometimes be easier to use, and this is actually a formula we were introduced to back in chapter 2 when we talked about slopes and rates of change. So instead we could use the limit as h approaches 0 of f of a plus h plus f of a over h. And again, remember that if you're given the point that the line goes through, you know a and you know f of a. So I'm going to show you now how to use this formula in example 2. Find an equation of a tangent line to the curve y equals x cubed minus 2x plus 3 at the point 1, 2. So if you know that this is a and this is f of a, then what we can, or we can call it, no, we'll call it a and f of a. All right, so what we can do is we can do f of 1 minus h, because we just said a was 1, minus f of 1 divided by h, and then find its limit. I just didn't write that to the left of it. So let's start with f of 1 minus h, because that's kind of the nasty one here. I don't normally give problems this nasty, but I want to do a quick review here. One of the things we learned was something called Pascal's triangle, which was a way of multiplying out things that are raised to higher powers other than 2 very quickly. If you remember, Pascal's triangle was 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, where the first row was row 0. That means what you get when you raise something to 0 power, to the first power, to the second power, to the third power. So 1 minus h, when I cube it, is going to be 1 cubed, and then it's going to be plus 3 times 1 squared times negative h, plus 3 times 1 times negative h squared, and then plus 1 times negative h to the third, which is going to be 1 minus 3h plus 3h squared minus h cubed. Now I can do this part of the problem, which is going to be negative 2 plus 2h, and then put the plus 3 at the end, and that's f of 1 minus h. Now I'm going to tack on minus f of 1, so minus, well, f of 1 is 2. And then we're going to divide that by h and then find the limit. So let's do some simplifying. I have a 1, minus 2 is negative 1, plus 3 is 2, minus 2 is 0. Awesome. These all go away. Let's see what else I have. I have a minus 3h and a 2h. That's going to give me negative h. I have a 3h squared. I have a minus h cubed. Maybe I'll write this in descending order of powers. And then that's going to be divided by h. Now when I divide everything by h, I'm going to get negative h squared plus 3h minus 1. We want to find the limit as h approaches 0. Well, if I plug in 0 for h, these go away and you're left with negative 1. Of course, now I realized that up here at the beginning, this should have been a plus. So that would have made all of these positive. Sorry about that. Everything would have been positive except for me subtracting 2 at the end. Ah, darn it. I'm sorry. I'm going to go back here real fast. My process was correct. What was incorrect was the fact that that should have been a plus 1. It should have been 1 plus 3h squared plus h cubed. And then my minus 2 minus 2h, and then my plus 3 at the end. And then I would subtract from that f of 1, which was 2. Now this should give me the right answer. So let's see, I have 1 minus 2 is negative 1, plus 3 is 2, minus 2 is 0, so those all went away. I have 3h minus 2h, which is 1h. I have an h cubed and a 3h squared. And then I'm going to divide those all by h, and I'm going to get h squared plus 3h plus 1, and now when I plug in 0 for h, these go away, and I'm left with 1, which is the slope. So if the slope is 1 and it goes through the point 1, 2, the equation of the tangent line is y minus 2 is equal to 1, x minus 1. Finding the slope of a tangent line has another name. It's called finding the derivative of the function. So we're going to do another problem where we use this. In problem 3, let's find the derivative of f of x equals 5x squared plus 3x minus 1 at x equals 2. Or at 2, I should say. So that means a is 2. So, since a is 2, then to find the derivative, and we write it like this is pronounced f prime of 2. It is also called the first derivative of f at 2. We're going to do the limit as h approaches 0 of f of, well, a is 2, so 2 plus h, minus f of a is 2, divided by h. Okay, so now what happens when I plug in 2 plus h? F of 2 plus h, it's going to be 5 times 2 plus h squared, plus 3 times 2 plus h, minus 1. 2 plus h squared is 4 plus 4h plus h squared. I distribute it at the end. Now let's finish. 20 plus 20h plus 5h squared plus 6 plus 3h minus 1. That's f of 2 plus h. Now if I tack on my minus f of a, well, in order to find f of a, I just plug in 2 for a. So 5 times 2 squared is 20. 20 plus 6 is 26, minus 1 is 25. And we're going to divide that whole thing by h and then find the limit as h approaches 0. So now I'm going to combine my like terms. I have 20 minus 1 is 19, minus 25 is negative 6. I have a 20h and a 3h, that's 23h. Ooh, I missed my 6. Sorry, there was a 6 there too, so that's 6 and negative 6 cancel. I still have a 23h and I have a 5h squared, and then I'm going to divide everything by h and then find its limit. So when I divide everything by h, I get 23 plus 5h. And now the limit as h approaches 0, this goes away and you're left with 23. And that's the derivative. The derivative is just the slope of the line. Now let's work with a function that's a radical. Let f of x equal the square root of x. Find the first derivative of f of a. All right, so to find the first derivative, we're going to start with f of a plus h. Well, f of a plus h is the square root of a plus h, minus f of a. That's minus the square root of a. And then we're going to divide that by h. But we're going to have to do some mathematical manipulation in order to get that h gone in the denominator, a little bit different than the manipulation we did in the previous problem. When you're dealing with a problem in radicals, you're going to multiply by something called the conjugate of the numerator. The reason you multiply by the conjugate is because this is in the form a plus b, a minus b, which distributes very simply into a squared minus b squared. So I'm going to get a plus h minus a, because when you multiply these together, the square roots cancel, minus, when you multiply these together, the square roots cancel. But in the denominator, I'm not going to distribute it out. I'm going to leave it like this, because the numerator then simplifies into h. The a's cancel, you're left with h, but h over h is 1. So now I'm left with 1 over the square root of a plus h plus the square root of a. And now I can plug in 0 for h. When I do, this goes away, and I'm left with 1 over 2 the square root of a, because I have 2 square roots of a. Now that I know the expression for the derivative, now let's say I want to find the first derivative at 1. Well, all I have to do is plug in 1 for a, so the answer would be 1 over 2. If I wanted to find the first derivative at 4, I would just plug in 4, and I would get 1 over 4. And then if I wanted to find the first derivative at 9, I would just plug in 9. Square root of 9 is 3. 2 times 3 is 6. And that's the end of part 1.